Yes, as usual, this is Namsindra Alma Samrawit Ombokolos Charles Chemo Kango Centuries Baribus Yatakira Chirema Mapere the genius. Every day I appear in the video like this, I just analyze matters of air conditioning and refrigeration engineering. Now for today, I'm always here to answer questions that people are posting on my page. Now they are asking me, why, what makes the air conditioning system, more so the outdoor unit, to give out very dirty oil or very dirty substance from the charging valve? So there are very many scenarios that can explain this. The reason as to why such things come out, there are very many reasons, and I'm trying to break them down. One, there could be the lubricating oil may be burnt. When the lubricating oil is burnt, of course the valve will have to give out the dirty substance. Now, what makes the lubricating oil to burn? One, if the condenser is blocked, such that all the heat which is generated in the compressor remains within the compressor, so that one burns the oil. Also, if the place where the compressor is, there is not enough saturation, so that the heat exchange can take place, that one can also affect the oil. The other one, there could be low refrigerant charge in the system. Now, if there is not enough refrigerant in the system, all the heat, which means there will be no cooling. And if there is no cooling, because from the law of thermodynamics, we know that heat moves from high temperature to low temperature. Therefore, if there is no cooling, which means all the heat will remain in the system. Now, the burning of the lubricating oil leads to another very big factor. That one we call it the mechanical wear. Now, the mechanical wear in the system mostly affect the rings, the piston, the crankshaft, and all the internal structure of the compressor. Now, when there is wear in the system, it means all the metal shavings fall in the compressor to mix with the oil and the refrigerant, and that is why you always see the dirty particles coming out. The third item that makes the valve to give out dirty substance is the moisture contamination. Now, in the other previous video, I explained the reaction that takes place when the moisture content enters the system, the reaction between the refrigerant and the oil, that forms the acid. So I don't want to go into that, but you know when the moisture mixes with the refrigerant together with the oil, there is a reaction that leads to formation of two different forms of acid, as I explained in the other previous video. That is hydrochloric acid and hydrofluoric acid. Now, these acids, while it is formed in the system, it attacks the compressor windings. Now, when it has attacked the compressor windings, it means the end result will be the metal salt in the compressor. Therefore, there will be small substances that will mix up with the refrigerant and the oil, so that all the passage where the refrigerant should pass is blocked. Therefore, it looks for the shortest way possible. So it affects the charging valve, so that it makes like it is an overflow. Now, to explain all these things I have stated, we base on three different forms of laws, or three different types of laws. One is the Dalton's pressure law. So, when there is moisture in the system, it increases the total pressure. Now, when the total pressure increases, it means the boiling point changes to high. Now, when the boiling point increases, it means the overheating also increases. And this one leads to high, or it speeds up the decomposition of metals in the compressor. Another law is the first law of thermodynamics. The first law of thermodynamics tells us that the energy is not destroyed or lost, but it can only be transformed. Therefore, if all the energy that is generated in the compressor it remains in the compressor. Why? Because there is no passage. Maybe the condenser is blocked, there is no passage. So all the energy remains in the compressor. It does not go on anywhere. So when it remains, it affects the internal structure of the compressor. Now, the second law of thermodynamics also explains the same thing, because the second law of thermodynamics tells us that heat moves from high to low, or from high temperature to low temperature, or from where there is high heat to where there is cooling. Now, in this case, there is no cooling in the system. Therefore, heat cannot move. There is no difference in the heat distribution. It is the same, so it cannot move. All the heat generated in the compressor remains. Remember, the compressor is where all the heat is generated. I told you in the other previous video that the compressor increases the temperature and the pressure of the refrigerant. There is a small point in the compressor called the muffler where all the heat is generated. Therefore, this explains why the air conditioning system, especially the outdoor unit, gives out that substance.